So with the LangChain, this building AI agent becomes very easy. It can connect to any of the files and load. It can connect to any of the vector database. It can use any of the tools. You just mentioned the tools that it will go and provide access to that tool, and it will help us to connect to any of the database and pull the information. And if I want to execute any of the code, right, then this also will be done by LangChain.
Hey everyone, welcome to You Can Automate. In the previous session, we have learned what is AI agent and what are the different types of memory in the AI agent. If you have not watched the previous session, link is given in the description below. You can go and watch it so that you will have some continuity here. So in this session, we are going to learn what is LangChain, how it helps to build a AI agent and different types of memory in the LangChain, and what is state management in the LangChain and why it is useful in building the AI agent, and what is the difference between the LangChain and LLM.
So to build an AI agent, one of the framework is required. Without using a framework, it is very difficult to build any AI agents. Lot of coding is involved, lot of libraries we need to involve, and lot of code we need to write. So with the LangChain, this building AI agent becomes very easy. What it does is LangChain is a framework that provides the building block and abstraction needed to build. Similar to any of the framework which we have it in Java, Python. For building AI agents also, we have a specific framework so that it becomes faster to build any of the AI agent. In short, LangChain provides everything AI agent needs. So what it does is remembers the context, use tools, achieve goals. It provides a kind of a framework. Using that framework, we call different tools, we connect to a memory, we connect to LLM, all those things happens. Different things LangChain provides for any of the AI agent is model abstraction. So for example, there are n number of models available now. If I want to connect any of the model, each model has its own way of connecting. If I want to connect to OpenAI, it has a specific format of the code which I have to write it. If I have to connect to Gemini, then I need to write a specific code. So this LangChain solves that problem. So I just need to mention which model I need to connect. That's it. It will do a task for me. Then it provides templates for any of the given prompt, because when we are interacting with LLM, we need to provide the prompt. LangChain has built-in template that we can use it and interact with the LLM. And of course, we talked about different memory types. It provides a memory also, how the memory can be managed, all that type of memory. It has different ways of storing the different memories, so that also this LangChain provides. Tools and integration, as we talked about AI agent needs tools to perform any of the actions. So this LangChain provides a flexibility or a way to connect to a different tools to perform any of the action. So for example, if I want to connect to API, it has a built-in integration mechanism so that I just need to connect to API. I will not worry about any of the prerequisites or extra boilerplate code, whatever we have it, that I no need to write it. If I want to connect to database, then it will have a predefined components or plugins so that I can connect to a database. Then it provides a chain. That means combine the components. So when we are building any of the AI agent, we require multiple things. The first thing is the LLM. To LLM, we need to provide the prompt, and we require tools, memory, etc. All these things will be connected and it will be linked in a chain. That's why we call it as a LangChain. And it provides some agents also. There are some pre-built agents to perform specific tasks which is already solved, like React, OpenAI functions, plan and execute. Some of the predefined agents, we can directly use it and do our specific task. And it helps to retrieve any of the information that could be from vector database, right, and any of the quadrant database, relevant information, whatever we wanted, that it helps us to retrieve those information. And we talked about the decision making, right? AI agent will do a learning based on the what result it gave, right? LangChain will help us to do that. It will do a callbacks and observability. It will do monitor and trace agent runs. After each run, it will keep track of like what was the input, what was the output, all those things, logging, streaming, and the token usage. This is very important. How many tokens LLM has consumed, all these details will be stored by LangChain. And here Langsmith is a different concept that we'll discuss later, that is not as part of the AI agent as of now. And this shows that how AI agent is orchestrated by LangChain is it provides a reasoning, decide and a plan, use tools. It will help us to use different tools, and it will help us to use a memory also. Then it will provide a response, and finally it goes as an output. And all these things, all the steps which are involved here, this will go in iteration mode till we get the final output. And when it comes to tools or different sources, right, it LangChain provides a way to connect to everything. It can connect to any of the files and load. It can connect to any of the vector database. It can use any of the tools. You just mentioned the tools that it will go and provide access to that tool, and it will help us to connect to any of the database and pull the information. And if I want to execute any of the code, right, then this also will be done by LangChain. So then why we need LangChain? We can build AI agent without LangChain also, but with the LangChain we can do a faster development. Our AI agent becomes more modular and flexible. If I want to do any changes in the AI agent, I can do it very easily. Production ready, we can easily go to a production without spending much effort in developing, and it is scalable. If I want to connect that AI agent with a different AI agent, then it is very scalable and model agnostic. So every day there will be a multiple LLMs will be releasing in the market. If I want to connect to a new LLM, then I need to go and change the code. That is not required with the use of LangChain. So observe and improve. As we are executing a prompt, it will go and observe all the input and output. So if you want to say, LangChain gives your AI agent the brain, memory, tools and connections required to get things done. So we have understood about the LangChain. Now let's understand the different types and examples of the memory. This is very important concept in AI agent. So memory lets your LLM powered application remember and use information across interactions. So while interacting with the AI agents, it has to remember everything what interaction we are doing as a user with the AI agent. While doing interaction, that the memory is split into a different types. That different types are conversational buffer memory. That means that if user says that who won the T20 World Cup in 2024, the AI agent says that India has won the T20 World Cup. Then the user asks question, player of the tournament. Then it provides the player name who got the man of the match, right? If you consider how it stores is what the question asked by user, what are different conversations which happened between the user and the AI, that it remembers and it will provide you the memory. That is nothing but the conversation memory. Second thing is a conversation buffer window memory, that it stores a specific information, only the last 4 conversations or last 5 conversations it stores. So for example, AI gives some answer on specific topic, then user asks some other question, then AI answers for that, then user says thanks. So all that conversations, if I say k equals to 4, only last 4 conversations it will remember, the remaining it will not save it. This is what we call it as a conversation buffer window. So here we can define the window at what is the window size it should remember. The third thing is a conversation summary memory. If I'm talking to AI agent by asking different questions, in this particular type of memory, it will store as a summary. It will create a summary between all the conversation, then it will store it. For example, user is planning to trip to Japan next month, interested in cities so and so, and this is the weather he is expecting, and they like cultural experiences and nature. This is the summary of the conversation which I have interacted with the AI agent. Fourth thing is a vector store retrieve memory. Here what it does is embeds messages and stores in a vector DB, and whenever there is a ask, it retrieves only the most relevant information based on the current query. So this is how it stores in the vector database. For each statement, it provides some scoring. Based on that, it will store it as part of the vector database. The fifth thing is an entity memory. What it does is extract and remembers entities based on people, places, and their details. If you consider Google Maps or something, it will remember all the places we have visited, right? Then it will ask us to provide a feedback. Similar to that, it keeps memory based on the entities. Entities could be a person. Say for example, Rohan is a person name, lives in some city, and then where he works is Google. And another entity could be a company name. What is a company name? Google is a company name, where it located and country. Similarly, if I take any of the other city, then it says that Bangalore is a city, and then where it is located, all those details it will store it in a form of entities. That is what we call it as a entity memory. Sixth thing is a custom memory. What it does is you can define, as a user, I can define what to store, how to store, and when to store it. So it is customized memory. I can say that project deadline is so and so, project name is AI chatbot, all that information which I require, that I can store it however I want. The question comes, are we going to use all these memory types in the LangChain? No. Here it says that different memory types solves different problems. Choose the right one based on your application needs. So in these memory types, we need to know what is the best suitable for our problem statement. Then we need to choose that memory type while building a AI. That we'll learn in the future. Then the next topic is a state management in LangChain. What is state management? When we are interacting with the AI agent, there is different states, different actions or different steps is involved in the AI agent. To remember what step is executed, what is the status of that particular step, we require something called state management. This is provided by LangChain. State management allows LangChain applications and agents to persist, update and share information across different steps what is happening. State is the information your application or agent remembers, updates while it runs. While AI agent is doing some task, it will remember what is happening and what is the result of it. So how this state management flow is, user provides the information, loads the data, process the information, update the state, then it will save that information in one of the file or a database, it could be anything, and that continues. Every time any of the action happens, that it will go and store that result into one of the place. For example, here I say that, hey, my name is Alex. It says that, okay, nice to meet you, Alex. The result is my name is Alex, that it stores. The next statement, I say that I live in Berlin. Agent responds that, got it, Berlin is a beautiful city. Then it updates that name is Alex, city is Berlin. Like that, after every input or the output, it will go and save the input and the output. That is nothing but the state. So what is the key takeaway here is, state management is a backbone of a reliable, context-aware AI application. To build any of the AI agent in a better way, state management plays a very important role here to remember each action and what is the outcome of it. So here this state management is provided by LangChain as a built-in, so that we can go and use it without any extra code. So now we have understood the LangChain. Now small question might come, then what is the difference between LLM and LangChain? So LLM nothing but the large language models. Example are GPT, Gemini, Llama, Mistral, all these things we call it as a LLM. What it does is, it takes input in a natural language, generates a text, learns the patterns and provide raw intelligence. What LangChain is a framework that helps you to connect LLM with external data, tools, memory and workflows. So here you can consider like LLM is a brain, and all the memory whatever which stores in the brain which comes from LangChain. So LangChain, it gives the brain memory, tools and actions. Based on all this memory, tools, everything, then brain will take some action. So here LangChain provides a prompt management, data connection, observability, deployment ready, everything the framework provides here. So here if you consider some of the differences here, LLM is AI model trained on massive data, but LangChain is just a framework which will help to build an AI agent. So one of the example here is, LLM is an engine, LangChain is the car framework. LLM understand and generate text, LangChain orchestrate, connect, enable actions. LLM thinks, LangChain makes it useful. So LLM here acts as a brain here. LLM has a knowledge, LangChain adds capabilities. So here LLM and LangChain, they work together. So this is about the AI agent and the LangChain, and what is difference between LLM and the LangChain. So as we are going to build AI agents, this is very important to know all these concepts and the terminologies. So go through this and let me know if you have any questions in this. Thank you.